This is week 7 of CNST 1731. This week we will be talking about roofs. We have built our foundation, we have built our walls, now we need to put something over it. So what does a roof do? The roof is going to cover the building, so it needs to be structural. It also needs to keep out the elements, so it needs to be impervious. The simplest kind of roof is a flat roof. It's basically another floor without the walls. However, they can be hard to drain because there isn't enough slope for the water to leave. And as a result, there are greater structural requirements of a flat roof because of the potential for accumulated water and snow adding to the weight. On the other hand, a pitched roof or a sloped roof has less structural requirements because the additional load of standing water or snow doesn't exist. So we do tend to get better drainage with a pitched roof. But if I have to put equipment on the rooftop, such as heating and ventilating systems, air conditioning units, it becomes a little harder to do because I don't have the flat surface. So the flat roof looks like this, is sometimes known as a built-up roof. The built-up roof will consist of 3 to 5 different layers of asphalt saturated roofing bonded together with a hot tar or an asphalt. This is otherwise known as roofing felt. The final layer will be coated with gravel to provide a wearing surface for any maintenance people who are on the roof and as a protection to the underlying tar and asphalt. Most of the time you will find built-up roofs being used for flat roofs. You will not see a built-up roof being used on a pitched roof. The official abbreviation for a built-up roof, as you can see in your text, is a BUR for built-up roof. Keep in mind that the term flat roof is misleading because built-up roofs will have a slope for drainage. It will not be as steep as you would find in a pitched roof, but a completely flat roof would be undesirable. And sometimes a secondary drain is required. That is, there will be a drain on the roof that will remove most water. However, anybody who has had to clean out a gutter in Northeast Ohio knows that leaves and debris can build up around that drain. So there's sometimes a secondary drain 2 to 3 inches above the primary drain that if the water gets that high, it can start draining that way, so the additional load of accumulated water does not exceed a undesirable amount. And this is what it looks like as somebody is installing the roofing felt with the hot tar or asphalt. The pitched or sloped roof. The pitch of the roof is defined as the vertical rise divided by the horizontal distance. And that horizontal distance is also called the run. It's usually expressed as a ratio of inches of rise to inches of run. and the run is usually based on 12 inches, so that we might have a roof that is 1 to 12, 4 to 12, 12 to 12. That means a 1-inch rise for 12 inches of run, a 4-inch rise for 12 inches of run, a 12-inch rise for 12 inches of run. The higher that the first number is, the steeper the pitch of or slope of the roof. And here are some examples. 012 is a completely flat roof, and you can see as these first numbers increase, the roof gets steeper and steeper. You can have something as high as 19 to 12. This would be a roof that would drain water very quickly. Keep in mind that the flatter the rise to run, the greater the span underneath that roof is for the height. Obviously, to cover this much distance with this kind of roof, you would need to extend it further down, which means you have a lot of space in here that may or may not be usable. This diagram will show you some of the terms used for a traditional pitched roof. Rafters extend from a ridge board. This is a hip roof, so there are rafters known as hip rafters. This is a gable roof which intersects with this hip roof. Not seen here will be the joists that extend from between the rafters, tying the boards together. And this is a picture of someone installing a roof using traditional rafters and ridge board. This is the ridge board, and these are the rafters, and down below connecting them will be the joists. Notice it requires a temporary support to keep the ridge board up. Now, one feature of pitched roofs is the eave, which are edges of the roof that overhang the face of the wall. And they will normally project beyond the side of a building to throw water clear of the walls, because we don't want the water, when it rains, to come down the side of the building. Sometimes the eaves will include gutters that will collect the water that comes off the roof and direct it to drains or downspouts. And this is an example of what an eave will look like. Here's the overhang of the wall, and here's a cross-section of it. Here's the rafter, a drip edge which might be replaced with a gutter. The soffit covers this area, and this whole section here is referred to as the eave. Here, by the way, is the hurricane clip where we're talking about the Simpson hangers in a previous presentation. So when you see the word eaves, this is what they are talking about. Now, sometimes roofs are created with prefabricated roof trusses. In this case, there is no longer a ridge board. We still have rafters and we still have joists, except now we call them top and bottom chords. There may also be a truss web to provide additional stiffening to the truss, but these trusses will all be connected with metal plates that are nailed in to hold this in place. And these particular trusses can be pre-engineered, already designed, in this case for northern Indiana, for design loads at 2 feet on centers, up to 24-inch overhangs, meaning the eaves. Different pitches, 4 and 12, 5 and 12, 6 and 12. This pitch here would be a rise of 6 inches for a run of 12 inches. Some different types of shapes of roof. We talked just a bit ago about a hipped roof and a gable roof. So this is a flat roof. A shed roof is simply almost half of a gable. The hipped roof, the mansard roof, a gambrel, almost a barn-shaped type roof, and the standard gable roof. Keep in mind what the different roof shapes look like. Roofs have to be designed, as we saw in the slide concerning the pre-engineered wood trusses. What loads do we need to support on the roof? There are two types of loads. One is the dead load. That includes the weight of the structure, the weight of the components, the lumber or the steel joists that are being used to build the roof, and any rooftop equipment. As discussed previously, air conditioning or air handling equipment. In some cities like New York, very high-rise buildings will have a water tower on the roof because there is insufficient water pressure to get water up to the 20th or 30th floor. Instead, a pump will overnight pump it to a water tower, and the water tower will provide the pressure for the floors below it, not unlike the water towers in our communities here in Ohio. Then there's the live load. For a roof, the live load will be any maintenance personnel that'll have to go on the roof, any repair supplies or tools that they have to bring along, and wind and snow loads that may affect the roof. And all those go into the design of a roof. Another aspect of roofing is the structural insulated panel, otherwise known as an SIP. And it consists of two outer skins, usually plywood or OSB, which is oriented strand board. In construction methods and materials, we will talk about what oriented strand board is. But for now, think of it as something similar to plywood. And there's an insulating foam in between them. So basically, it is a sandwich. And you can see how they are installed here to form not only a structural surface, but one that is insulated as well. The structural insulated panel has a insulating foam, usually of expanded polystyrene. We can get them in sizes from 4 foot by 6 foot to 8 foot by 24 foot. Obviously, the bigger sizes will require fewer pieces to cover a given area, but they will be heavier and more costly per piece, and because they are heavier, may require more specialized or expensive equipment in order to lift them to the roof. So that's always the trade-off that you have. They are structurally rated. They will provide lateral strength. That means being pushed from the side, uniform load capacity that we were just talking about. And they can be used not only for roofs, but for walls of buildings. So let's take a look at some drawings that talk about roofs. We're going to start with the brick veneer residence, sheet number 5, and we're looking at this portion of it. Notice sheet number 5 has the floor framing plan, which we've talked about previously. It also has the roof framing plan. So let's take a closer look at this, and we see that we have a 2x8 ridge board. Notice they leave off the inch signs. This is wood, and it is 2 inches by 8 inches. We have rafters that are 2x6s. They're 18 feet long, 16 inches on center. And we have joists, also 2x6s. They are 24 feet long, and they are 16 inches also on center. Obviously, they will be the same on center as the rafters because they are connected to each other. In construction, it is usually recommended that the rafters which meet at the ridge board are directly opposite each other. This way, loads transferred from this rafter will go directly into this rafter, as opposed to being offset, which could cause a twisting motion. If we turn to Shaw Place sheet A2.1, we see the exteriors of a very elegant Victorian-looking building, perhaps not unlike the New York brownstones, which get their name from the material used to face the building, basically a brown sandstone, but became known as the type of building that used it. But if we notice, we have a section here and here which refers us to sheet A3.2. And looking at this area, we see that there's a hidden area on the roof that is flat. Notice we have a pitch here, but it doesn't go all the way up, and this area here is used for equipment, roof access, but these little walls or parapets will shield what exists and goes on up here from anyone down below, therefore making it look a little bit better. Still, we don't know what is up there, what is being hidden from view. So for that, we turn to sheet A1.12. So if we look at the roof plan, so let's take a closer look at the roof plan on this sheet. The first thing I want to draw your attention to is the plan north. Once again, we don't have north pointing straight up, as one might imagine, but pointing to the left, telling us that this is the north wall, east, west, and south. It does not line up with geographic north, but it helps define or identify the various sides of the building. So what are we looking at? Well, we see here we have air conditioning condensers, and looks like we have 4 on this side and 4 on this side. We have something called RTU1 and RTU2. These are ordinarily rooftop units, and that's what the RTU stands for. and it's some sort of mechanical equipment that is necessary, and it could very well be for the elevators. Notice we also have this telling me to slope my roof in this direction to where my drains are. We also have skylights on both sides, as well as roof access in one location. Notice where I have roof access, I also have something that calls for a double roof layer. In this area where access might be for maintenance personnel, we want a little bit stronger roof layer. Remember, this is a flat built-up roof, to be able to withstand the extra traffic that will occur here as skylights, rooftop units, and air conditioning units are serviced. Notice this area over here also calls for a double roof layer, as well as in the center where these particular pieces of equipment might be maintained, requiring men and tools to be in this area. And over here we have something called a cricket, an aluminum cricket. Now, a cricket is basically a peak-shaped structure on the roof. It's a small false roof behind a projection such as a chimney. Nobody really quite knows where it came from. It might have, they suspect it might have been from the British game of cricket or croquet, because the roof cricket is shaped like an arch, similar to the one used in both these games. It's sometimes called a saddle. It's designed to shed water away from the chimney or other projection on the roof, usually capped with a large piece of sheet metal flashing. And we see here aluminum valley flashing being called out. Speaking of flashing, what exactly is that? Well, parts of a roof are prone to leaks, and these are valleys where two planes connect, the intersection between a dormer wall and the roof, chimney, skylight perimeters, anywhere that we're going to have extra heavy runoff, or where two surfaces at different angles will meet. So that flashing is providing extra protection at that intersection. Usually it's a rust-resistant metal such as galvanized sheet metal, but aluminum and copper will sometimes be used as well. Certain types, chimney flashing is obviously applied around the base of a chimney where it meets the roof. Continuous flashing, joints between vertical walls and a sloped roof. Skylights sometimes have their own integral flashing. Step flashing, steps up a roof to protect where the roof is going to meet side walls of dormer, chimneys, certain skylights. Valley flashing, where two roof planes meet, where a roof at one angle meets the roof at another angle and creates a valley. And in vent pipe flashing, fits over flues, which are chimneys or pipes, such as exhaust pipes on the sanitary system. And here is an example of the different types of flashing that is available. And here you see somebody installing one around a flue pipe, and you can see it fits onto the roof and protects that area where the shingles meet with it, and it's usually caulked as well. Looking at some of the details on this sheet, detail 1, the air conditioning mounting. Notice it calls out the roof trusses that support it, a 6-inch by 3/8 inch channel supporting angles, a concrete pad, and rubber isolation strips to dampen any vibration that may occur in the air conditioning, so it does not get transmitted to the structure. Notice the gas furnace flue here. We call this a 1-hour rated shaft and 1-inch gypsum board fire separation. This is designed because there's heat coming out of here, and we want to make sure that if a fire starts in a fireplace or a furnace and proceeds up the flue, that we have some protection to the rest of the structure. Notice it talks about an air intake and telling you to see mechanical drawings. So one of the reasons for Rule 1, you have to look at all of the drawings. Even if you are not the mechanical contractor, there may be something in these drawings that will affect how you build this structure. Sections 3 and 4, what I wanted to point out was this continuous vent space that allows air to move through the roof structure underneath the roof, but between the roof and the insulation, and escape outside into the atmosphere so that we don't get a buildup of heat on the roof. And notice the call out for 2 by 10 rafters, 24 inches on center. We have a specification for insulation, and we'll talk about insulation and R ratings when we discuss exteriors and insulation, mechanical, electrical next week. But notice it says to maintain air passage for all joist cells in the roof structure. Again, these are designed to make sure that we don't get hot spots and freezing and thawing and the creation of ice dams. And that ends week 7.